Hi everyone, welcome to SIG Node weekly meeting May 7, 2024. We have one topic on the agenda today. So it's Marcus and Zwonko regarding passing CRI resources to the CRI. Go ahead.
Okay, yeah, I'm sharing my presentation. Is it visible to you folks?
Yeah.
Okay,
Yeah.
cool. Yeah, I am Zvonko, and today talking a bit more about the KEP 4112, which is passing down resource information from Kubernetes to CRI. The problem we're trying to solve here is that resource requirements are not visible to the container runtime at sandbox creation at all, basically. So we are talking about like native resources, host devices, CDI devices, and mounts here. And native resources, I mean Kubernetes CPU and memory requests and limits, and then extended resources as well. And that causes issues in certain scenarios. Here are the use cases that we are most interested in for the time being. So for Kata, the hypervisor at the VM creation time needs to create, for example, the PCI device topology for the upcoming containers. And then confidential containers is another sort of VM-based scenario where we want to allocate all resources kind of statically at the VM creation and then not do any changes to the VM kind of resources after the pod sandbox has been created. And then another scenario is customized resource management, for example, by using NRI plugins, vendor or application specific scenarios. For example, optimizing or doing some optimizations on resource placement or reservation already at sandbox creation time. The goals of the KEP are pretty short in this list. So make the required resources visible at the sandbox creation time, and make the resource spec of containers visible to CRI as well. And this means now the resource requests and limits basically from the pod spec. And non-goals, we don't definitely want to touch any of the Kubernetes resource management code or logic, or how Kubernetes or Kubernetes behaves. And also we are not proposing to make any kind of backwards incompatible changes or anything. So the CRI runtime can continue to operate as it did before these extensions. The proposed solution in short is that the kubelet already now has virtually everything prepared at the sandbox creation, like mounts and devices, and it has virtually all information already. So we propose to extend the CRI API to kind of have a I call it here forward lookup on things on COM So for this kata confidential containers NRI use cases, and then I guess there are others as well. For example, WASM. In the future, that could benefit from this. For example, WASM runtimes doing resource management. And basically, the idea is that those runtimes or usage scenarios that don't want or don't need this forward lookups, so kind of normal scenarios, then can basically ignore the information and continue with continue to operate as they do already now. And here's the last slide of mine is a kind of example on the API level how the kind of pod spec would translate into CRI pod sandbox request. So in this example, the pod sandbox run pod sandbox request would then have a new field that basically lists all containers, and here we have a Kubernetes resources, CDI devices, mounts, and so on. And that's basically what I had to present, like intro. What is the current proposal?
So I think last time you all raised it, someone had raised security concerns. I'm not sure. Tim Allclair did you have some security concerns with this? If I remember.
I can't remember having any security concerns. My concerns were more around how much of a dependency this is adding on. Maybe that's not quite the right way of phrasing it, but basically, this requires the runtime to understand a lot more details of the pod lifecycle than was previously the case. And the example that I gave in the KEP was that it wasn't taking sidecar containers into account, and the changes to pod lifecycle around sidecar containers. Now that's kind of a one-off case that sure we can update the KEP to address it. But my concern is that as more, as we add and change things in the future, it's going to make it a lot harder to change aspects of the pod lifecycle and require us to handle version skew with the CRI in a way that we haven't had to in the past.
So, go ahead, Marcus.
Yeah, I don't. Has anybody? Okay, yeah, I think that is a fair concern, kind of from this perspective. The kind of mitigation of this would be the kind of would be that only the specialized use cases would actually depend on this functionality. So like kata confidential containers or similar, or NRI plugins, or some specialized non-RunC runtimes. Oh, Tim raised a hand.
Yeah, this is kind of turning this into a much bigger conversation, but I almost wonder if the current CRI API is not quite the right plugin point for this. It almost seems like we need a new extension point for runtimes that require much greater control over the whole pod. Not sure exactly what that would look like, but I worry about us trying to shoehorn it into the existing CRI and making things a lot more complicated for container-focused runtimes.
Another option may be to kind of use runtime classes and like add it as metadata that can be only attached for these cases. If you are not quite ready to like rethink the whole pod life cycle and pushing it down to the runtime. Sorry, Sasha, you have your hand up.
Oh, no worries. I wanted to address a bit of team concerns. So, yes, providing this information down to runtime classes in the container runtimes, CRI and containerd, it will, well, definitely it will provide more flexibility to runtimes like Kata or similar VM-based runtimes. And indeed, they will be more hooked to like container lifecycle or pod lifecycle in general. However, right now we have completely the opposite extreme, is what the kubelet is assuming a lot how the implementation of containers and pods are done in the low layers. And these assumptions are actually dragging us behind in the technology. So like this example of secure VMs and so on. So Kata, I don't remember, like 3 years ago, implemented this pod summary just to mitigate like create sandbox or create VM of right size. But now we have confidential VMs where the devices needs to be provisioned at the VM creation time and afterwards cannot be changed. So these assumptions, what was added 3 years ago, become not valid. So if we start to adding like more and more these assumptions of how the runtime classes are implemented, or like if for this runtime class we are giving that information, for this runtime class we are not giving that information, we are just creating like more and more spaghetti code of if defs for future functionality. So it's in my opinion, it's a lot better to have CRI API describing like really descriptive interface, like what we are trying to run. If we are creating a pod, then describe what will be part of this pod.
Yep. I mean, it makes sense because we are eventually sending the same data. It's just that when that data is sent upfront or in pieces later on. And
yeah.
Yeah.
So practically, it's the same set of data. It's just about the timing on the control sequence. So it was making sense to not send the data back in the Docker times because the Docker didn't have the like entity of pod or group of containers. So we were creating, like the kubelet was doing it manually practically, like the post container and so on. But nowadays, both CRI and containerd, we have our own internal entity about the pod. So like the shim, which also communicates to low layer runtimes like Kata or whatever else behind the runtime class, this information is valuable there.
So there's one aspect where there'll be some duplication of logic, right? Like, say, if you want to calculate the memory assigned to the pod, then you'll have to, if you get the entire pod spec, then you'll have to look at, okay, what's the size of your biggest init container? Also make sure you're adding the sidecars. So the question is, does it make sense for that logic to be duplicated across the kubelet and runtime? And sometimes it's not in sync, or
it makes sense to have this logic
aggregate and send it down.
No, aggregation will kill the whole purpose. It's more about probably to have this logic as a library, so whoever needs it to actually use it as a library. The problem with aggregation is what it's really runtime dependent. So for, let's say, like if you're based like run C or C run based runtimes, you can easily aggregate. In case of VM based, you don't really know how much of overhead or how much of like over provisioning of resources VM want to have. And it usually wants to predict it more carefully inside of it, inside the runtime implementation.
Yeah.
So I mean, at any point, if we are trying to summarize something, we are making assumptions how it's going to be implemented on runtime, and what, like in few years, it will lead to another problem saying this API again needs to be changed.
Yeah.
Yeah, I just wanted to hop in. I want to mention for we have an NRI plugin that we've developed, right? And one of the problems with it is like we at the pod sandbox creation time, it's exactly this. We don't have all the information. So what we ended up doing is having to query the Kubernetes API server to get the pod spec at the NRI plugin time, right? So I think this would actually solve that problem, which is pretty awesome. Maybe one comment I have though is has there been thought about maybe instead of piecemealing like the approaches here, just to include some part of maybe the whole pod spec in that call, or maybe some stripped down version of the pod spec, for example, removing some sensitive information.
I think the pod spec is overkill. Sorry, for interrupting you, because otherwise we will end up in practically virtual kubelet kind of project, where like the whole runtime implementation is somewhere outside. As Marco said, like all of these changes is all about providing the exact information which is already present in the CRI protocol, just different timing.
Yeah, and for the mounts, for example, we want to kind of resolved host path, not the data from the pod spec.
If we pass the pod spec, we have to re-implement a lot of the kubelet logic, right, to convert that into. What's possible.
Yeah, I think that makes sense. What I'm more thinking is like, for example, if the runtime needs to understand, for example, what's the difference in an init container versus the sidecar container versus the main container, something like that, right? But maybe
we can try to generalize it by sending the container list and when the information how much this container will be running. Like, is it like one short? Is it full-time running container or something?
I mean, if we really need that information, it can be like an additional field, right, next to the container describing it.
That's the current proposal, is that it's kind of this container type in the API. But of course, then the runtime side needs to be aware of all the different container types, init, sidecar, regular.
Right. Larry, you have your hand up. Right.
Yeah, so I asked a question in the chat. I figured I'd just ask though. So, and I don't know that I necessarily worded it correctly anyway, but is there any concern about maybe the staleness of the information being presented? We talk about this being run at runtime, and obviously static pods would kind of handle that, right? Because it's all static devices, they can't be removed. But when it's a standard or dynamic pod, what would be the case of representing the information of what's available to the pod, and then maybe a device is hot swapped on the node? Has that been thought through, or are there any insights on that?
Well, the hot swap of devices at all not supported.
Yep, that's entirely new.
Yeah, and update container resources, of course, if kind of in place updates happen, then of course it cannot be captured at pod sandbox creation time.
But when it's again like the update container while it's running, it can return the proper error if, for example, like with confidential VMs cannot be resized. It will just say like I cannot change this container.
Yes.
All right. Any more thoughts? So, like, there's already a cap, right, Marcus and Zonko? So, is it up to date? So basically, we just need a review on the cap, right? And
Yes. Well, yeah, it's up to date. There are some probably now late feedback from Tim and somebody else there was, but I at least haven't responded yet. But yeah, it's the cap is up to date for review.
okay, I mean, we can track it for 131 if yeah, there are no critical blockers. Yes.
Yeah, I can hand it over to Zvonko. He's going to present in more details in the kind of kata use case and with a demo as well.
Sure, Mrinal, can you give me access?
I think I gave you co-host. Yeah, so you should be able to share.
Okay, let me just check. I hope this is the right screen. Slideshow.
Yep, can see.
Can you see? Okay, great. I just wanted to go not really step by step, but what actually happens when we are creating a kata pod and a sequence of events that are happening and why we need the additional information at the create sandbox time, and how it helps in the kata use case and additionally also in the confidential containers use case. I'm primarily looking here from the GPU side of things, but it applies to all VFIO devices being pass-through. For example, on S390D VFIO AP devices or NICs or any device that can be virtualized and pass-through into a VM. So this status quo is, right, the CRI issues a run pod sandbox containerd over the containerd shim-v2 signals to kata runtime to create a sandbox. Kata runtime starts the VM, and at the start VM time, we are assuming on the sizing of the VM, where we're saying, okay, we have some default memory that we are issuing, like with 2 gigabytes, a default set of vCPUs. And for the GPU use case, we have also assumption that we're saying, okay, we can set the amount of PCIe root ports where we are attaching or hot plugging the GPU to it at 2. So maybe someone would ask, hey, why are you not maxing this out? Well, we can max this out, but then we are not leaving space for any other devices. We have hypervisor limitations, and the maximal amount of PCI root ports is 16. It can differ for other hypervisors, but for some workloads, we can say, okay, let's assume we are only going to attach like 2 GPUs or 2 devices that are going to the PCI root port. What's the problem here? We don't know how many containers per pod are coming in, how many containers are going to allocate a VFIO device, what resources per container are used, how much memory is each container using, how much CPUs is each memory using, how many extended resources are allocated per container that are coming with this pod, and also how many CDI devices are attached per container. All those things we cannot deduce with the current CRI API, and hence that's why we have hot plugging in the first place with kata containers. So after the sandbox is created with the post container, there's a new create container requests. The container comes in with 4 CPUs, 4 gigabytes of memory, and a def VFIO device. which means on the other end at the kata runtime, we are hot plugging the amount of vCPUs, hot plugging the memory, and we are hot plugging the GPU at the first root port. Container number 2 comes in. Okay, we can still allocate some CPUs and memory. Another VFIO device comes in, and we are hot plugging the GPU2 at root port number 2. As we've seen in the before, we made the assumption that we only have like 2 PCI root ports. Now container 3 comes in with a third GPU, and this is where it breaks the use case, because we assumed we will only need 2 PCI root ports. The third container will not start, hence the pod will not start. I mean, we can max it out to 16, but what if we have like one container allocating 8 GPUs, the second container allocating another 8 GPUs? We are still breaking the VM. So this is where in the kata use case, regarding the GPU, where without having the right information at VM, at the pod sandbox creation time, where we don't have enough information, where it breaks kata. And then for confidential containers, the other use case is, again, the same. It's all cold plugged. Hot plug is disabled per default for VM, CPU, and VFIO devices as well. And we can not do any reconfiguration of the VM. And we don't want to do reconfiguration of the VM in a confidential environment. So again, the same questions arise. What we are doing, how many containers are coming per pod, resources per container, extended resources, CDI devices. We have already existing pass-through annotations in container D that are accumulating, like the CPU period, CPU quota, CPU share, and memory. But again, as said before, this should be really the decision how those things are accumulated with overheads and stuff be done by the endpoint, be it the kata runtime or any other sandbox environment, to deduce how much of those resources need to be allocated for the sandbox. And with the cap, we have, for the init sidecar and regular containers, we have the resources, CPU, memory. We have all the CDI devices that are either provided by a CDI device plugin or later on by DRA, and we have the mounts. We are excluding extended resources from this cap because container D will, because extended resources can be named arbitrarily, and in the kata runtime, we don't need how to map Linux devices to specific extended resources. With CDI, we know that because we have this handle, we have the name, and we can look up in the CDI spec how a specific Linux device looks like. And at every stage, be it in the CRI, in container D, or in the kata runtime, we can look up every device by its name in the CDI spec database. So we always know how a device is going to be mounted or what container edits we need to do in the OCI spec to enable this device inside of the container. What we're doing is at the sandbox creation time, we are getting all the resources and the CDI devices. I only concentrated on the CDI devices for this demo and for this presentation. So what we're doing, we are taking the CDI devices. Container D does a pass-through of those CDI devices as a OCI spec annotation. And the kata runtime can interpret those annotations, can look up the devices, decide if it's a GPU, and if it's a GPU and a PCI Express device, it can create the PCI Express topology at the pod sandbox creation time, meaning all the CDI devices that are needed later on for all containers that are coming are available at the pod sandbox creation. So the PCI topology is correctly created, and we do not have to keep track of how much containers are coming because all the information is already there. And yeah, start VM, and we have the CDI specs available, and we can create all those devices. The question that's not answered is how are we pass-throughing all the amount of mounts, CDI devices, and all other resources through container D or cryo in a way to the end runtime, which is consuming it, because we don't want to containerd or CRI-O to convert the runtime config into an OCI spec, because the post container does not need the VFIO devices. So it needs to be some meta information. And this is the big question, how we are going to, pass through all those meta information consistently in containerd, CRI-O, or any other runtime to the end runtime, which is consuming it. So container 1 comes in with the request of CPU, memory, and the CDI devices. In this case, containerd converts the CDI device into a VFIO device, and the Kata runtime can just hot plug or cold plug the GPU to the root port. The same for container 2 and container 3. All works now because we have configured the PCI topology in the right way, because we know upfront how many GPUs are coming due to the CDI devices being available at pod sandbox creation time. Yeah, as I mentioned before, how we are encoding the pod resource config structure through containerd or CRI-O, and we cannot map we cannot map infinite containers to one OCI spec. So we have a specific amount of containers, and we can only have one OCI spec. And as I said before, CDI can be read by any entity in the stack. How are we mapping those features that do not map to CDI, like the mounts or the resources, CPU and memory? Let me just see what's that. This is again cold hot plug thing. Okay, I think it's time for the demo. Do you guys see the terminals? Is it big enough? Should I increase the font size?
It's fine for me. Maybe you may want to bump up the font size a couple of sizes.
Yeah, let me do
that's
that.
better. Yeah.
Okay. So we have a pod with 3 containers. Each of those containers is allocating a GPU as a CDI device. I have a simple device plugin running, which is based on CDI. So this device plugin will allocate a CDI device and put it into the CRI. Apply Ubuntu. So what happened, what we see here on the kubelet side is the additional structure which is passed through the CRI. We have all the CDI devices with indexes for each of those containers. We have container 0, we have container 1, and container 2. On containerd side, it's taking those CDI devices and creating the CDI annotations. On Kata side, we are taking those annotations and creating the actual container edits with the CDI spec. And let me just see container creating. It takes some time to allocate all the GPUs, but just to showcase that I disabled the PCI root port stuff. So meaning Kata will, in this case, deduce the amount of PCI root ports that we need to create a PCI topology by this new pod resource config. And just to showcase, let me just see if the pod is running. KXA Ubuntu GPU pod. It's actually doing something. Oh. To container 0, and we have the GPU running. Yeah, that's a small demo. Any questions?
The pass-through stuff you mentioned, right? That's something we would want to ensure is consistent between different runtimes. So So
Yeah.
any ideas you can put around that in the KEP will be useful.
Yeah, I need to think about how we can, map all the resources from all containers to one OCI spec. So how we are providing like this meta information. I mean, we cannot map everything to a CDI device. If we could do that, this would be nice. So then we can say, okay, what we are only supporting is CDI devices. And then we can extend the CDI spec with all the things that were needed. But I don't know how we are going to, extrapolate that into meta information that we can easily pass through. And I don't think that, having like thousands of annotations is also the right way. Maybe it is as a beginning, but we need to think about how we are, pass-throughing all those information through the runtime, from converting it from the runtime config into a OCI spec.
Yep. Good. Thanks for the demo.
Thanks, Mike.
Okay. All right. So we don't have any other topics on the agenda. If folks want to raise something, now is a good time, or we can get back 20 minutes.
Just side comment about all of this. So during the KubeCon on OCI group meeting, I was trying to raise the idea of adding into OCI runtime specification the entity which will be matching a group of containers. So like pod, sandbox, whatever you call it, the idea is to have like more matching to real world OCI runtime spec where we have several containers running as a group. I haven't started the issue in OCI specification yet about all of this, but if somebody interested to join the forces, please contact me.
Okay, sure. Be sure to loop in the Podman folks as well, because Podman has a concept of pod of containers that run together, similar to Kubernetes. So,
yeah,
interested to get that. Yep.
Well, that's exactly what I was talking about, like matching the real world. So nowadays, nobody is using single container. Like most of the usages is like Docker Compose, Kubernetes, Podman, and so on. So it's time to bring this concept to OCI.
It is. We talked about it in the OCI meeting last week. We want to put together a work group, Alexander. It's a good idea. Or at least some of us do. We can at least propose it.
Yeah, I promised during the KubeCon to folks what I will look how to document it and like outline some of my ideas. And I did some of the research for like how to fit it into existing OCI spec, but it doesn't look nice. So probably I will just like brain dump like my my brain into as an issue, and let's have it as a starting point for discussion.
Yeah, perhaps a new index manifest type. But yeah,
something like bundle of bundles of configuration files. I don't really like how it looks in the first draft, but hey, let's start the discussion.
Sounds good.
Sounds good. Folks, so we have one more agenda topic that Yuju added. Let's discuss it. Yuju, you want to talk about the C group suite to memory issue?
Yeah, sure. So I came across this issue, I think, a couple of times. It was also mentioned in the C group v1 deprecation or maintenance mode cap. And I tried to trace the discussion. I follow the discussion, but there seem to be two opinions. One is like, this is a bug. There's a discrepancy in how the counting and usage is reported on C group v1 versus v2. And there's another camp of the opinion that this is just more accurate as in terms of the kernel memory counting and everything. So it's not really a bug. So I just wanted to get some more opinions from this group to see if this is something that we need to tackle, or if from the SIG we think this is a natural evolution of the memory accounting, and this is we don't need to pay more attention to it.
So I think I'll have to refresh my memory, Yuju, but will this break nodes? Like when someone switches from V1 to V2, will pods no longer fit due to this? Or is it the other way around?
I think the memory usage report would be higher for that pod, but the overall, yeah, so that I guess could be one consequence.
Okay.
But whether that's intentional as in more accurate, we didn't charge the sum of the usage to the pod correctly before. Now we're doing it. I'm not too sure. That's why I wanted to see if anyone has studied this more thoroughly previously.
I can chime in just a couple, just my 2 cents. So, one thing here, so like this is mostly about the usage, not the capacity, right? So from the pod scheduling perspective, right, it should be unaffected, right? Because scheduling it's all about the capacity reported. I think the history on this one, like I remember we were talking about it. So like I think what happened basically is that we switched to SIG V2 and we saw that the usage went higher, and then there was a fix that went into run C to kind of change the accounting to kind of exclude some certain types of memory to kind of bring down the usage. And then I think there was some more discussion about if that was actually the right fix, and that if now we're in a state where we're not accounting some things in the usage. So specifically, I think there was a comment on that run C issue, where I think like some certain types of kernel memory may no longer be accounted in the run C calculation that we're using. So I think it's kind of a question goes down to like whether we think we have the right knowledge of how exactly to sum up the different type of kernel, different types of memory types, right? Or if we should just trust the information that's coming directly from the kernel, even if it is higher on SIG V2. I think that's sort of like the main question here, as I see it.
Okay. I think we have a kernel expert that we can reach out to. Maybe Peter, we can reach out to Wyman and get his take. And I basically, I think any input from kernel folks will be very useful to know exactly what the difference is between V1 and V2, and if we should change anything.
Yeah, I think getting some folks who have some more experience there would be very helpful, for sure.
No, that would be great. Thanks.
Yeah, okay. I'll take an action to follow up with the kernel folks and then get back. All right. Thanks for raising this. This is important as we're talking about C groups V1 feature freeze. All right. Anything else, folks? Okay. Thanks for joining. See you all next week. Bye now.
Thank you.